All right, let's take a look at the practice tests. For the instructions, we're asked to determine whether the points are collinear. So looking at problem 1, here we have -1 comma -2, we have 1 comma 8, and then we have -2 comma -7. So how can we determine if these points are collinear, meaning they lie on the same line? Well, one way you could do this is with the distance formula. So you're going to find the distance between each pair of points, and you're going to take those two smaller distances and you're going to sum them and see if it equals the largest distance. Now, before we do this, I'm just going to note that this is the slowest possible method, or maybe the most tedious possible method that you can use to figure this out. If you want to do this in the quickest way possible, you need to look up the method on matrices, which I do have a video on later on in this course. Okay, so you can go to that if you're just trying to do this in the quickest way possible. If your teacher told you to do this using the distance formula, then this is what you want to do. So let's first go to the coordinate plane, just to give you a visualization of what's going on. You can see that these points are going to be collinear, but I'm going to prove this to you. So here's 1 comma 8, here's -1 comma -2, and here is -2 comma -7. So in other words, you want to find the distance from this point to this point, and then you want to find the distance from this point to this point, and then you want to find the distance from this point to this point right here, and the sum of the two smaller distances equals the largest distance. So let's do that real quick. So first we're going to work with 1 comma 8, and then we're going to work with -1 comma -2, and then we're going to work with -1 comma -2, and we're going to work with -2 comma -7, and then lastly, and this looks like a 21, so let me make that a little bit cleaner there. Then lastly, we're going to do 1 comma 8 going down to -2 comma -7. Okay, let me grab this, and let me just paste this in here, and I'll put myself a little room there. I'm just going to label everything really quickly. So this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. And then let me come down here and say this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. And then this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. Okay, so we're just going to plug into the distance formula. So the distance is equal to the square root of, you have this x sub 2 minus x sub 1 quantity squared, plus you have this y sub 2 minus y sub 1 quantity squared. Okay, so let me just go, the distance is equal to the square root of, I'm just going to start with this one up here. And so we're going to say that x sub 2 is -1, and then minus x sub 1 is 1. So this is quantity squared, plus y sub 2 is -2, and then minus y sub 1 is going to be 8, so this is quantity squared. So -1 minus 1 is -2, and if you square -2, you're going to get 4. So let's write a 4 there. And then here, -2 minus 8 is going to be -10, and if you square -10, you're going to get 100. So this is 4 plus 100, which is 104, underneath my square root symbol. So what is 104? Well, I know it's divisible by 4. 104 would be 4 times 26, and 4 is a perfect square. So let's write 4 times 26 like this. Square root of 4 is 2, so this is 2 times the square root of 26 for the distance between these two. So let me just put this as the distance sub 1, just so we can keep track of them, and I'll just arrow to this. And now we'll say the distance sub 2, and I'll just arrow to this, is equal to the square root of. So for x sub 2, we're going to have -2, and then minus for x sub 1, we're going to have -1. So minus -1 is plus 1, quantity squared. Then plus for y sub 2, we have -7, and then minus for y sub 1, it's -2. So minus -2 is plus 2, quantity squared. So -2 plus 1 is going to be -1. So -1 squared is going to be 1. And then -7 plus 2 is -5. So -5 being squared is going to be 25. So 1 plus 25 is 26. So this is the square root of 26. Obviously, 26 is 13 times 2, so you can't make that any simpler. And then let me say this is d sub 3 here. I'm just going to arrow to this. So this is the square root of. So x sub 2 is -2. And then minus x sub 1 is 1. And this is quantity squared. And then plus y sub 2 is -7. And then minus y sub 1 is 8. And this is quantity squared. So this right here, -2 minus 1 is -3. So this is -3 being squared. -3 being squared is going to be 9. And then -7 minus 8 is -15. And then -15 being squared is going to be 225. And so 9 plus 225, that's going to be 234. So this is the square root of 234. So to simplify this, first I'm going to divide by 2. And I'm going to say that this is 2 times 117. Now 117 is divisible by 9. 1 plus 1 is 2, 2 plus 7 is 9. So if I divide that by 9 in my calculator, I'm going to get 13. So this is 9 times 13 like this. So 9 is a perfect square. The square root of 9 is 3. So we can say this is 3 times the square root. So 3 times the square root of 26. We know these are the two smaller distances, and this is the largest one. And you can see this is going to work out. 2 times square root of 26 plus, you could say 1 times square root of 26 would be 3 times square root of 26. Let me just grab this real quick. Let me just come back here. I'm just going to paste this in. And basically what we're saying is the distance from here down to here, this is going to be 2 times the square root of 26. And then the distance from here going down to here, that is going to be the square root of 26, or you could put 1 times square root of 26. And we're just saying if we sum these two together, we get this 3 times square root of 26. So then going from right here to right here, this is going to be 3 times the square root of 26. So yeah, this is going to be collinear. Obviously, you can see it because I've graphed it, but you just do 2 times square root of 26 plus 1 times square root of 26 is this equal to 3 times square root of 26. So always the two smaller lengths being added together is equal to the largest guy, okay, the largest length. So this would be 3 times square root of 26 is equal to 3 times square root of 26. So yes, this is true. So these are collinear points. We can just come back up here and say yes. All right, let's take a look at problem 2. So here we have the points 3, 1, -2, -1, and -8, 8. So again, I've already plotted these guys. So here's your -8, 8. Here's your 3, 1. Here's your -2, -1. So we can see that these points are not collinear. This forms a triangle. But again, I'm going to show you this using the distance formula method. And I just want to state again, this is the slowest possible method to do this. It's only something you want to use if your teacher makes you do it because you're in that section. So let's go ahead and just first say that I want this distance here. So that's going to be from -8, 8. And this is going to 3, 1. Let's label this as D sub 1. Maybe that'll be helpful. And I'll just arrow to this and say it's D sub 1. And then let's say we have a D sub 2, and I'll arrow to that and say this is my D sub 2. We would have 3, 1, and then going to -2, -1. And then let's call this one right here D sub 3. And so for D sub 3, we're going to have -2, -1 going to -8, 8. All right, let's grab these and let me space this out a little bit so we can label some things. I'm just going to label everything now just to save a little time. So let's just say this is X sub 1 and this is Y sub 1 and this is X sub 2 and then Y sub 2. And then what I'm going to do is double label this. So I'm just going to put X sub 1 and then Y sub 1 and then X sub 2 and then Y sub 2. And what I mean by double label, I'm just going to arrow here and then arrow here. And then here, 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 and then here. So let's write out our distance formula for reference. So the distance between 2 points on the coordinate plane is equal to the square root of, you're going to have this X sub 2 minus X sub 1 quantity squared, then plus your Y sub 2 minus Y sub 1 quantity squared. For the first one, D sub 1, let me just write D here. We'll put the square root of, for X sub 2, that's going to be 3. And then minus, for X sub 1, you have -8. So minus a -8 is plus 8. This is quantity squared. Then plus, for Y sub 2, that's 1. Then minus, for Y sub 1, that's going to be 8. And this is quantity squared. So 3 plus 8 is 11. So this right here would be 11 squared. And we know that's 121. And then 1 minus 8 is going to be -7. So this would be -7 being squared, which would be 49. So if we think about 121 plus 49, that's going to be 170. So this is the square root of 170. Now for 170, it's 17, which is a prime number, times 10, which is 5 times 2. So you really can't make that any simpler. This right here is equal to the square root of 170. And let's move on to this D sub 2 here. So for the X sub 2, we have -2. And then minus for X sub 1, we have 3, quantity squared. Then plus, for Y sub 2, we have -1. And then minus for Y sub 1, we have 1, and this is quantity squared. All right, so -2 minus 3 is -5. So this right here would be -5 being squared. So that is 25. And then over here, -1 minus 1 is -2. And then -2 being squared is going to be 4. So 25 plus 4 is going to be 29. So this is the square root of 29, and 29 is a prime number, so we can't simplify that. So let's get rid of this. And I'll say this equals the square root of 29. And let's just slide this up just a little bit. And now let's go on to the last one here. So for x sub 2, we have negative 8. And then minus for x sub 1, it's negative 2. So minus a negative is plus a positive, so this is plus 2. And this is a quantity squared. And then plus for y sub 2, it's going to be 8. And then minus for y sub 1, it's going to be negative 1. So minus a negative 1 is plus 1. And this is quantity squared. So looking at this, negative 8 plus 2 is going to be negative 6. So negative 6 being squared is going to be 36. And then over here, 8 plus 1 is 9. So this would be 9 squared, which is going to be 81. So 36 plus 81, that would give me 117. And the square root of 117 can be simplified. If you think about 117, it's 9 times 13. So the square root of 9 is 3. So you could put this as 3 times the square root of 13. Let's scooch this up and put equals. So I'm just going to put 3 times the square root of 13. And let me paste this in. For d sub 1, which is the distance from this point to this point, or you could say the length of the side of this triangle, this is the square root of 170. So let me write that in here. This is the square root of 170. Maybe I'll change that arrow. And then for d sub 2, that's the distance from here to here, or the length of this side of the triangle. We'll say this is the square root of 29. And then for d sub 3, this right here is 3 times the square root of 13. And maybe I'll just change that arrow up a little bit like that. Okay. So if we look at this visually, I think you can see that the square root of 170 is going to be the greatest distance, in other words, from here to here. It's hard to actually estimate things. You know that the square root of 170 is going to be larger than the square root of 29, but what about 3 times the square root of 13? There are certain techniques you can use for this, but to not go off on some sort of tangent here, I'm just going to use my calculator. I'm going to punch in the square root of 170, and let's say I get about 13. So just about 13, that's me rounding to the nearest tenth. And if I do 3 times square root of 13, I get about, let's just say 10.8, just rounding to the nearest tenth. Okay, you can do this one too, even though you know this one's going to be the smallest. That one would be about 5.4 if you round to the nearest tenth. So which one is the largest? What's the square root of 170, right? You can see that visually, that this guy right here is the longest side of this triangle. Now let's think about our little rule. We said that we would take the two smaller distances and sum them together and see if it equals the largest. Okay, so in other words, I would take this 3 times the square root of 13 and add that to the square root of 29 and say, does that equal the square root of 170? Just using the estimations here, you can see this is not going to work. But of course, you could just punch it into your calculator. 3 times square root of 13 plus the square root of 29, that would give me about, and I'm just going to round to the nearest tenth, let's just say 16.2. Is this equal to the square root of 170? We said that's about 13. So obviously these are not equal. You could put the not equal to symbol there. You could also just put false. I'll just do that one here. 2 different ways to show that. But we know that this is not going to work itself out where we say that the points are collinear. Obviously, looking at it, they form a triangle. So if we go back up, we would just say no, these points are not collinear. All right, let's take a look at problem 3. So here we have 4, 0. We have -1, 5, and 8, -4. So coming down to the coordinate plane, here's your -1, 5, your 4, 0, and your 8, -4. So you can see clearly we're going to have collinear points, but let's prove that. So let's first find this guy right here, this distance, and then we want to find this distance right here. And then we're going to sum those. Those are the 2 smaller distances. It should be equal to this distance right here, the largest distance. So let's just go ahead and say we're looking for the distance from -1, 5, then to 4, 0. Let's call that distance 1, and I'll label this as distance 1. This will be distance 2, and then this will be distance 3. So let's say for distance 2, this is going to be from 4, 0 going to 8, -4. Maybe the negative could be a little bit better there. And let me slide this out of the way like this. And I didn't mean to drag this over here. So then for distance 3, this is the biggest one. So from -1, 5 going to 8, -4. Okay, let's grab this real quick and we'll paste this in. Let me put a little border. And let me separate this stuff a little bit like this. And I'm just going to label everything now, get that out of the way. So let's say this is x sub 1 and y sub 1. This is x sub 2 and y sub 2. And I'll just draw an arrow like this and this. So let me just copy this and I'll paste this in here and then do that like that. And we'll say that the distance is equal to the square root of, again, you have your x sub 2 minus x sub 1 quantity squared plus your y sub 2 minus y sub 1 quantity squared. So the distance is equal to the square root of, for x sub 2, it's 4. And then minus for x sub 1, it's negative 1. So minus the negative 1 is plus 1. This is quantity squared. Plus for y sub 2, we have 0. And then minus for y sub 1, we have 5. And this is quantity squared. So 4 plus 1 is 5. 5 squared is 25. And then here, 0 minus 5 would be negative 5. Negative 5 squared is also 25. So let's write this 25 plus 25, or 50, as 2 times 25. And so the square root of 25 is 5. So this is 5 times square root of 2. So the first one is going to be 5 times the square root of 2. Okay, for the second one, we'll say the distance is equal to the square root of. For x sub 2, you have 8. And then minus for x sub 1, you have 4. This is quantity squared. And then plus for y sub 2, you have negative 4. And then minus for y sub 1, you have 0. And this is quantity squared. So 8 minus 4 is 4. 4 squared is 16. So then negative 4 minus 0 is negative 4. And then negative 4 squared is going to be 16. So 16 plus 16 is 32. But I would write that as 2 times 16, since 16 is a perfect square. So the square root of 16 is 4. So this is 4 times the square root of 2. And I'll just drag this over here like this and say this is d sub 2. Maybe move this equal sign over here. And then for this one, let's say that the distance is equal to the square root of. For x sub 2, let me slide this up. X sub 2 is going to be 8. And then minus x sub 1, that's negative 1. So minus the negative 1 is plus 1, quantity squared, plus. For y sub 2, it's going to be negative 4. And then minus for y sub 1, it's going to be 5, and then quantity squared. So 8 plus 1 is 9. 9 squared is 81. And then negative 4 minus 5 is negative 9. Negative 9 squared is also 81. So 81 is a perfect square. So you could do 81 plus 81. That's 162. But it's better to do 2 times 81 here, because 81, the square root of that is going to be 9. So this is 9 times square root of 2. So let me get rid of this and say this equals 9 times square root of 2. So for d sub 1, this is 5 times square root of 2. For d sub 2, this is 4 times square root of 2. And of course, if you add those together, you are going to get the largest distance here, which is 9 times the square root of 2. So let me go ahead and show that. So officially, you take 5 times square root of 2 plus 4 times square root of 2. So again, the two smaller distances, you sum them and you set it equal to the largest distance, which is 9 times square root of 2. And you see, is this a true statement? Well, yeah, 5 plus 4 would be 9 times the square root of 2. And that equals 9 times square root of 2. So yes, these points are collinear. So coming back up here, we would just put yes. All right, let's take a look at problem 4. So here we have negative 2 comma negative 1. We have negative 3 comma negative 3. And then we have 3 halves, or you could put 1.5 comma 6. So again, everything is plotted. We have 3 halves comma 6. We have negative 2 comma negative 1. And then negative 3 comma negative 3. So these points are going to be collinear. But again, let's prove this. So you want the distance from here to here. And then you want the distance from, let me do this in a different color, here to here. So those would be the two shorter distances. Let's just label this. You don't have to, but I'm just going to call this d sub 1 and this d sub 2. And then the largest distance here, like that, let's go ahead and call that d sub 3. So this plus this has to be equal to this if we have collinear points, meaning they lie on the same line. So let's go ahead and say that for d sub 1, this is going to be what? So it's from negative 3 comma negative 3 going to negative 2 comma negative 1. And then for d sub 2, let me make this d a little bit better. We're going to have from negative 2 comma negative 1 going to 3 halves comma 6. And then for d sub 3, let's say that's going to be from 3 halves comma 6 going to, let me make this a little bit better, going to this negative 3. Let me make that better there, comma negative 3. Let me grab this real quick. So let me give myself a little bit of room to label things. Just slide this down and didn't mean to grab that. So let me put that back up there. And so let's say this is x sub 1 and then y sub 1 and then x sub 2 and then y sub 2. And I'm just going to arrow here and here and then here and here and then here and here and then here and here. And so I'm just going to copy this And let me paste that in there. So we're good to go with the labeling. So let's say the distance formula, d is equal to the square root of. You have x sub 2 minus x sub 1 quantity squared, plus you have y sub 2 minus y sub 1 quantity squared. All right, so what we're going to do here is say that the distance for this d sub 1 is equal to what? So the square root of, so x sub 2 is negative 2, and then minus x sub 1, that's negative 3, minus the negative is plus a positive, so this is plus 3, quantity squared, plus for y sub 2, it's negative 1, and then minus for y sub 1, it's negative 3, so minus the negative 3 is plus 3, the quantity squared. So negative 2 plus 3 is 1, 1 squared is 1. Let's put 1 there. Negative 1 plus 3 is going to be 2, 2 squared is 4. So this right here is the square root of 5. d sub 1 is equal to the square root of 5. All right, for d sub 2, your x sub 2 is 3 halves, so you have 3 halves. And then minus your x sub 1 is negative 2. So that would be plus 2. Because we have a fraction here, let's write 2 as 4 over 2. So 4 over 2. Let me straighten this up a little bit like this. And this would be quantity squared. Maybe that could be a little bit longer than plus. Over here you have y sub 2, which is 6, and then minus y sub 1, which is negative 1. So minus the negative 1 is plus 1. This is quantity squared. All right, so 3 halves plus 4 halves is going to be 7 halves. So this is 7 halves, or 3.5. So if I square this, I'm going to get 49 fourths. So let's say this is 49 fourths. Okay, over here, this is 6 plus 1, which is 7. 7 squared is 49. So what I would do is actually get a common denominator. So I'd multiply this by 4 over 4. So 49 times 4 is 196. And then 49 plus 196, that would be 245. So this would be 245 over 4. So let's break this up and say this is the square root of 245 over the square root of 4. We can legally do that. So we know the square root of 4 is 2, so let me put 2 down there. And then up here, the square root of 245, well, you could write 245 as 5 times 49, and then 49, the square root of that is 7. So this would be 7 times the square root of 5 over 2. So let me get rid of this. Let me bring this up and say this equals. So you have 7 times square root of 5 over 2, like that. Let me get rid of that and put my square root symbol back in. Get rid of this and slide this up just a little bit. So we would say that this is x sub 2, which is negative 3, and then minus x sub 1, which is 3 halves. So 3 halves. And then this is quantity squared. Plus for y sub 2, that's negative 3. And then minus for y sub 1, that's 6. And this is quantity squared. So again, for this one, let's write negative 3 as negative 6 over 2. Basically, all I did was multiply. If you have negative 3 here, just multiply by 2 over 2. And you could write that as over 1. So this would be negative 6 over 2. So that's another way to write negative 3. Again, so that we have a common denominator. And so here, negative 6 minus 3 is negative 9. So this would be negative 9 halves. And if you square this, the negative goes away. 9 squared is 81. And then 2 squared is 4. So this would be 81 over 4. Maybe this could be a little bit deeper like that. So negative 3 minus 6 would be negative 9. And then negative 9 squared would be 81. So let's go ahead and say that I'm going to multiply this by 4 over 4. 81 times 4 is 324. So let's add 81 plus 324. That's going to be 405. So this would be 405 over 4. Okay, so let's split this up into the square root of 405 over the square root of 4. So we know the square root of 4 is 2. For 405, that's going to be 81 times 5. So let's write this as 81, which is a perfect square, times 5. So the square root of 81 is 9. So this is 9 times the square root of 5. Let's say this equals, you have 9 times the square root of 5 over 2. Okay, let's come back and paste this in. So this was our d sub 1. You can barely see it. So let me use a different color. I'm just going to arrow to it. So this is the square root of 5. So this is d sub 2. Let me use a different color and I'll arrow to that. So this is 7 times square root of 5 over 2. Maybe that could be a little bit better there. And then this down here, this d sub 3, which is hard to see. Let me do this in a different color. This is 9 times square root of 5 over 2. Okay, let's get rid of this. And again, some of these two smaller distances, it needs to be equal to this largest distance in order to prove that these points are collinear. Okay, so we're going to say that the square root of 5 plus 7 times the square root of 5 over 2 should be equal to 9 times the square root of 5 over 2. So I'm going to multiply this by 2 over 2. So let's say this is over 1 times 2 over 2. So you would have 2 times square root of 5, then plus 7 times square root of 5 over the common denominator of 2 is equal to 9 times the square root of 5 over 2. So 2 plus 7 is 9. So we would have 9 times the square root of 5 over 2 is equal to 9 times the square root of 5 over 2. So yes, this is a check. So these points are collinear. Obviously, you can see that because we've graphed a line here. But let's go ahead and go back up and say, yes, these points are collinear. All right, let's take a look at problem 5. So here we have -5 comma -5. We have -2 comma 0, and we have 0 comma 2. So let's come down here. We have the -2 comma 0, so I've arrowed to that. We have 0 comma 2, and then we have -5 comma -5. So obviously this forms a triangle, and so these points are not going to be collinear, meaning lying on the same line. But again, we could just prove this. So let's look at, I'm just going to call this piece right here, let's say D sub 1. So for D sub 1, this is going to be from -2 comma 0 going to 0 comma 2. And then for D sub 2, let's call that this piece right here. So D sub 2 is going to be from, let's see, -2 comma 0 going to this -5 comma -5. And then for D sub 3, let's say that's this piece right here. So clearly that would be the largest distance here, right? Because that's the longest side of this triangle that we're forming. So let's say that's from -5 comma -5 going to 0 comma 2. Okay, let's grab this real quick. And once again, let's write our distance formula. So the distance is equal to the square root of, you have this x sub 2 minus x sub 1 quantity squared, plus you have y sub 2 minus y sub 1 quantity squared. All right, so let me drag this down and drag this down. And what I'm going to do is say this is x sub 1 and then y sub 1, and I'll arrow up and then down like this, and kind of miss that one. So let me do that way. And then I'll say this is x sub 2 and then y sub 2. And again, I'll just arrow up and down. And then I'll just copy this, move that like that. And then everything is labeled. So now we can just roll through it. So for the first distance, it's equal to the square root of. So you want your x sub 2, which is 0, minus your x sub 1, which is -2. So minus a -2 is plus 2, quantity squared. So 2 squared would be 4. So then plus for y sub 2, you have 2. And then minus for y sub 1, you have 0. And this is quantity squared. So 2 minus 0 is 2. So this would be 2 squared or 4. So 4 plus 4 is 8. But I would actually write this as 2 times 4. Because 4 is a perfect square. Square root of 4 is 2. So this is 2 times square root of 2. So this, we'll say, is 2 times the square root of 2. Okay, for this D sub 2, let's say the distance is equal to the square root of, we have this x sub 2, which is -5. Let me make that a little bit clearer there. Minus for x sub 1, it's -2. So minus a -2 is plus 2. And then this is quantity squared. And then plus for y sub 2, it's -5. And then minus for y sub 1, it's going to be 0. So let me put that in there and say quantity squared. -5 plus 2 is going to be -3. So this is -3 squared. This is going to be 9. And then -5 minus 0 is -5. -5 squared is 25. So this right here, 9 plus 25 is 34. So this would be the square root of 34. And say this equals the square root of 34. Now 34 is 17 times 2, so you really can't make that any simpler. Okay, for the last one that we need to find, let's say the distance is equal to the square root of. For x sub 2, it's 0. And then minus for x sub 1, it's -5. So minus a -5 is plus 5, quantity squared, plus for y sub 2, it's 2. And then minus for y sub 1, it's -5. So minus a -5 is plus 5. And this is quantity squared. So 0 plus 5 is 5. So 5 squared would be 25. And then 2 plus 5 is 7. So this is 7 squared, which is 49. So 25 plus 49, that's going to be 74. So this is the square root of 74. Now 74 divided by 2 is 37, so you really can't do anything with this. And scooch this up here and say this equals the square root of 74. Okay, so let's paste this in here. And we have to be very careful about the approximations that we choose here because we're going to add these two guys together and set it equal to this one. Now we can see visually that this is not going to work, but if you were to take, let's say 2 times square root of 2, and let's say you approximate that to be about 2.8, So I'm going to add more decimal places in a moment. Let's just say for right now we put 2.8. And then here, let's approximate this to be about 5 point, let's say 8. And here, let's approximate this to be about 8.6. Well, what's going to happen is if you use these values, you're going to get, if you said 2.8 plus 5.8, is that equal to 8.6? Well, the answer is yes. But we can see that this isn't going to be true. So what's happening is it's going to be close, but because we're using an approximation and we're not using enough decimal places, we're not getting an accurate enough answer. So sometimes you could just round to the nearest tenth like we did here. But for this one, I would go a few decimal places out. Let me actually label this so that we're not lost in what we're doing. So this piece right here is going to be 2 times the square root of 2. And then this piece right here of this guy, this is going to be the square root of 34. And then this piece right here, let me do that in a different color. So this piece right here, this is going to be the square root of 74. Again, you can see this is a triangle, but it's got sides that are very close together. So let's go through here and say 2 times square root of 2 plus the square root of 34. Is that equal to the square root of 74? So I'm going to tell you that it's not, but again, if we use these approximations, it seems like it is. So let's just punch this into the calculator without approximating it first. I'm just going to get rid of this. And let's say that 2 times square root of 2 plus the square root of 34. And I'm going to round to the nearest 10,000th. So let me write some digits here. So we have 8.6 and then 5, 9, 3, 7, and then 9. So this is what my calculator gives me. There's also a 0 and then a 2, but we don't really need that. So we're going to round to the nearest 10,000th. So here's the tenths, hundredths, thousandths, and then this is the 10,000ths. So the digit that follows is a 7. So I'm going to cut these off and change this into a 4. Okay, so let's look at this. So the square root of 74. So I'm going to say, is this equal to, we have 8.602325267. So tenths, hundredths, thousandths, 10,000ths. So this is where I want to set my round off place. The digit that follows is a 2. So I'm going to cut that off. And now look at these guys. And clearly they're not the same. Okay. Again, when we did a rounding to the tenths place, it looked like they were the same. But if you punch this into your calculator and then round, and I rounded to the nearest 10,000th here, well, what's going to happen is you can clearly see they're not the same. So I'm going to say this is not equal to here. And so obviously these guys are not going to be collinear. You can see that from the sketch. If we come back up, I'm just going to put no.